Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI preparation and also for CMI. In today's session, I will be discussing paper of 2019 of ISI. As you know, ISI has two parts. One is UGA, which is having objective question, another is UGB. In today's session, I will be solving all the questions of UGA, and in next session, I will be taking UGB. And then in the next session, I will also be analyzing the entire paper, that from which topic how many questions were asked, how many questions were easy, how many questions were difficult. Okay, so all these things, doability of different questions, all these things I will be discussing in the next session. So let us start with solving of this UGA of 2019 B Stat or B Maths of ISI. So this is my first question. You are given 4x4 chessboard and asked to fill it with 3x1 piece and 1x1 piece. Then over all such fillings, the number of squares that can be occupied by 1x1 piece is. Options are 4, 8, 12, 16. Now, we can consider this kind of a square. Now, we are given 5 3x1, which will be occupying 15 1x1 box of these 4x4 square chessboard. I am calling this as one box. Okay, so such 15 boxes will be occupied by these 3x1 pieces, and remaining one box will be occupied by this 1x1 piece, so that this entire 4x4 chessboard is covered. So we don't have to overlap any box and we don't have to leave any box. We have to cover all these 16 boxes of this 4x4 chessboard. Now, one of the way could be that I start from this corner and I can put this 3x1 piece here. Then one more 3x1 piece I put it here. Then one more, I put it here. There is no overlapping as of now. One more here. So 4 3x1 pieces has been used. Now I am having 4 boxes in this vertical column, you can say. All of them are empty. So 3x1, if I use that remaining 3x1 piece, I think I can fill these 3 boxes like this, and the remaining one box of this 4x4 chessboard can be filled using 1x1 piece this way. So you can see all the 16 boxes of this chessboard are covered using these 5 3x1 and 1 1x1 pieces. In this case, 1x1 piece is occupying this corner space. Now, similar to this approach, I think we can easily see this corner could have been, this 1x1 piece could have been there in this corner also. It's very simple. I just have to fit this 3x1 or vertical piece in these 3 boxes in this right hand side vertical line, you can say, or column, you can say. And then this 1x1 piece will be fitting into this corner. Now, similar to this, we could have had this box into this corner also, this corner also. So it is very easy to see that there can be 4 choices for 1x1 piece. But what if we are not putting this 1x1 piece into corners, or we are putting this into either here or anywhere else other than these 4 corners? Let me mark these 4 corners this way. So if my 1x1 piece is not coming in these 4 corners, then these corner has to be filled using 3x1 piece only. In that case, we have 2 ways. Suppose I have to fill this corner using 3x1, so I will be putting one 3x1 piece either horizontally or vertically. I think they will be same thing. You can do it otherwise also. I am taking a horizontal 3x1 piece so that it covers this corner also and also other 2 boxes of this chessboard. Now, if I have to fill this also using a 3x1 piece, because no overlapping is allowed, so I think I should be putting it this way. Then only I will be able to fill this corner also, and these 3x1 piece will be covering 3 boxes of this chessboard which are not covered already, so that no overlapping is there. Similarly, to cover this corner, I think I will need to put this way. And similarly for this one, I think I need to put this way. But what you notice here, that if we do this, that means I do not put 1x1 piece in these 4 corners, then I will be having still one 3x1 piece and I will be having one 1:1 piece. So theoretically you can see I still having sufficient material to cover 4 boxes of this chessboard, but out of this 3:1 is having a dimension of 3 in one way and 3 length in one side you can say, and length 1 on the perpendicular side you can say. Then this 3:1 piece cannot cover these three boxes, because if you fill this way I think it is going to cover this box also, and then we will be having only 1:1 piece which can either cover this or this, and I will be having one box uncovered. So I hope you are getting that if we do not put 1:1 piece on these corners, we will not be able to cover the entire chessboard. In fact, we will be overlapping at one of the place and one of the box will be left uncovered. So answer for this has to be 4 only. Dear all, this question was a tricky one. In the exam pressure, it is not expected that we can very easily conclude that it will be 4. Sometimes it looks like there can be few more boxes where we can fill this one into one piece. So in exam I can say this question was little I can say difficult, or maybe average to difficult from the exam point of view. Okay, now coming to second question, we are given a brand called Jogger's Pride produces pair of shoes in 3 different units that are named U1, U2 and U3. These units produce 10%, 30%, 60% of the total output of the brand, with the chance that a pair of shoes being defective is 20%, 40% and 10% respectively. If a randomly selected pair of shoes from the combined output is found to be defective, what is the chance that pair was manufactured in the unit 3? So question says this Jogger's Pride is producing shoes in 3 different units, U1, U2, U3. U1 is producing 10% of the total production, U2 is producing 30% of the total, and remaining 60% is produced by unit U3. Out of these production of U1, 20% are defective, from U2 it is 40%, from U3 it is 10%. So first of all, to find the probability, once we know that randomly selected pair of shoes is defective, we should first find the total probability of defective shoes. This question is based on total probability law and Bayes theorem you can say. So first we will be finding the probability of total probability of shoes or pair of shoes becoming defective, and this can be done in 3 ways. It was produced in unit 1 and it is defective, or it was produced in unit 2 and it is defective, or it was produced in unit 3 and it is defective. So to find the probability of first one, first I will be writing the probability of that it was produced in unit 1 and then it was defective given that it was produced in unit 1. This is how total probability law work. Okay, similar to this and similar to this third term will be coming here. Now, so this total probability of a pair of shoe becoming defective becomes probability of U1 is I think 10%. So I can say 0.1 here, and being defective given that it was from unit 1 is 20%. So I will call this as 0.2. Similarly, 0.3 will be multiplied with 0.4 and then 0.6 will be multiplied with 0.1. So if you write all these probability, it is 0.02, it is 0.12, it is 0.06. So total becomes I think 0.20. Now they are asking if shoe was defective, for which we have found the probability is 0.2. What is the chances that pair was manufactured in unit 3? So actually we are looking for probability of unit 3 given that shoe was defective. So we will be writing probability of D here and we will be finding U3 intersection D here. So this thing here is nothing but I think this 0.6 into 0.1 or 0.06, and probability of defective is 0.20. So this becomes 3 upon 10, whom I can write as 30% also. So answer for this will be A. Okay, easy question, little bit of calculation, but easy question. Now coming to the question number 3. Consider a paper in the shape of an equilateral triangle ABC with circumcenter O and perimeter 9 units. So perimeter 9 units means side length will be 3. If we fold the paper in such a way that each of the vertices ABC gets identified with O, then area of the resulting shape in square units is. Dear all, we are given an equilateral triangle. That means all three sides are equal, and also circumcenter can be centroid also, can be orthocenter also, can be in center also, depending upon our requirement. Now, this is how the diagram could be. Here I have drawn this triangle ABC and all these are medians. I will rather like to call this circumcenter as centroid because they are same for equilateral triangle. Okay, so if it is centroid, the ratio here would be 2:1 here. Now if I want to fold the paper such that this A comes at O, then definitely my folding should be about the midpoint of AO. Let me call this point as J. And also this folding should be about the line that is perpendicular to AO also. So this dotted line is actually the perpendicular bisector of AO. So this J point will be such that AJ will be equal to JO and this will be equal to OD. Okay, so actually you can see this entire altitude or median will be actually divided into 3 equal parts: AJ, JO, OD. Okay, now let me show you how folding will be done. If I fold this A about this folded line, I think this is how my new figure will be. So this is what I have tried to show here. This portion will be deleted. Okay, and it will be coming to this O here. And as I told you, this A and this J and this is D, AJ, JO and OD, they all are equal. Okay, so this height of this triangle, let me call this as maybe XY here. So for the triangle AXY, the height will be 1/3 of this bigger triangle ABC. Okay, one more thing, because this is perpendicular bisector of AJ, perpendicular bisector of AO, so this XY will be parallel to BC. So this triangle AXY will be similar to triangle ABC, and the ratio of similarity will be 1:3 because this AJ is 1/3 of the AD. So because as I told you, this perimeter is 9, side length of equilateral triangle is 3, so this AY will be 1, then this will also be 1 similar to that, and this will also be 1 here. So what you can see that this is the figure for which we have to find the area, and you can see it is just devoid of the 3 triangles like AXY, which is also similar to bigger triangle ABC. So my required area will be actually area of triangle ABC minus 3 times area of triangle AXY, because AXY has ratio 1:3 with ABC. I think this area of triangle AXY will be equal to 1/9 of triangle 1/9 of area of triangle ABC. Why I am saying 1/9? Because ratio of the corresponding side length is 1:3. So area should have ratio 1:9, because to find the area I have to multiply side 2 times. So 3 into 3, 9, it will be like this. So here it will become area of triangle ABC minus 1/3 area of triangle ABC. So it is actually 2/3 of area of triangle ABC. And let me write the area of triangle ABC, which is equilateral triangle, so I can use the formula √3/4 into side square, and side of triangle ABC was 3, so 3 square here. So this 3 will cancel this 3 square 3 times, this 2 will cancel 4 2 times. So if I write answer here, it will be 3√3/2. So my answer for this has to be C. Okay, now coming to next question. We are given, let P be a regular 12-sided polygon the number of right angle triangles formed by the vertices of P is. So if we are given regular 12-sided polygon, I can think of it being inscribed in a circle such that all the vertices lying on that circumference, and they are dividing the circumference into 12 equal parts, starting from this 1, then 2, then 3, all the side length 1 to 2, or you can say the arc length, they all will be equal. If you compare arc length 1 to 2, 2 to 3, they all will be equal. Now, as they are asking number of right angle triangles, so number of right angle triangle means I have to have one hypotenuse, okay, and because this hypotenuse should have two vertices from these 12, so I have to choose two such vertices which are diametrically opposite. Why I am saying diametrically opposite? Let me join 1 with 7 which are diametrically opposite in this circle, because if you have chosen 1 and 7, then whatever vertex now you choose, your triangle is going to be right angle triangle only at that vertex which we are now going to choose. It will not be 90 degree at 1, it will not be 90 degree at 7, but it will be 90 degree at that third vertex that I am going to choose. So first of all, how many such diameter can exist for this 12-sided regular polygon? I think it will be 6, because 1 will be making pair with 7, 2 will be making with 8, and so on. So there will be 6 number of ways for 6 diameters. Okay, and then for any diameter chosen already, I am still having 10 vertices from whom I can choose. So 6 into 10 will be the answer. So that is the answer here. You can think of it otherwise also. Let me tell you the idea that you can think of that I will first choose at which vertex I want angle to be 90. Okay, so first you can choose any vertex out of these 12 in 12 ways. Suppose it is 3. It could have been 2 also, it could have been 1, it could have been anything. So if you choose vertex 3 where 90 degree will be the angle when we are selecting 3 vertex, then definitely I will not be selecting 9, because if 3 and 9 they are selected, they will be diameter. So any third vertex if chosen, you cannot have angle 90 at 3. So what I am going to have, if 3 is to be the vertex where angle will be 90 degree, okay, then I will not choose the remaining vertices as 9. 3 is already chosen. I think then I will be choosing from 4, 5, 6, 7, 8, 10, 11, 12, 1 or 2. But I have to choose such that if I am choosing 4, then along with 4 I have to choose 10, so that they are diameter and they will be able to form 90 degree at 3. So this is how this 90 degree angle will be. It could be this way also, that you choose 6 and 12, they are also diametrically opposite, then 6, 12 will be forming angle 90 degree at 3. So first we will be selecting which vertex at angle will be 90 degree, and vertex opposite to it or diametrically opposite to it cannot be selected. Then from remaining 8, remaining I think 10, yeah, 1, 2, 3, 4, 5 plus 5, 10. So you are having 10 vertices from which we will be having 5 pair of vertices which are diametrically opposite. So from these 5 we can choose any one of them and we will get a right angle triangle. So it is also giving us answer is 60. I think both of them are easy. Okay, it is just how you approach it at the first sight, but it is easy in any sense. Okay, now coming to the next question, question number 5. It says if the n terms a1, a2, a3, an are in AP with increment r, increment I think they mean to say that common difference, then the difference between mean of their squares and square of their mean is. Dear all, this question if you will do by taking a1, a2, an, it can be difficult, but let me tell you, if you understand the concept of variance of some data is nothing but what they are asking here. It is actually mean of the squares. It is mean of the square means sigma ai square upon n minus sigma ai upon n whole square. This is what variance is. That's a very standard concept. It is done in 11th standard where mean variance is taught. So you should know. And there is one very important property, let me tell you. Actually, this result is a shortcut to find this variance. In fact, we in the beginning defined this variance as sigma of ai minus a bar. A bar means the mean of the data square upon n. So it can be proved that this expression and this expression, they both are equal. It is just simple. You just have to open this bracket. It can be proved. Okay. Now, because of this thing, there is one very important property of this, that if you decrease or increase your data by same number, your variance doesn't change. So if I am looking for variance of A1, A2 and so on AN, and if I reduce every data by same number, my variance will not change. Why it is so? Because if you reduce every data by same number, your mean will also change by the same number. So every AI and A bar, they are reduced by same number, then their difference will also not be changed. So variance, whether you find find for A1, A2, AN, or you find for another data which we have obtained from this A1, A2, AN only, but by subtracting by a fixed number. For example, if I subtract this every data, subtract by A1 minus R. Why I have done A1 minus R? You will very soon come to know. If I subtract every data by A1 minus R, I think this one will become R, first one. A2 will become 2R, yes or no? Because A2 minus A1 plus R, so it will be 2R. Next it would be 3R and so on, and then the last one will be NR. You can check. So actually we have to find this variance of this data for R, 2R, 3R and for NR. In fact, R can be taken common, okay, and in this variance it will come as R square outside. Okay, so let us see how this will be done. Let me write this data once again. So my data is actually, or rather I should say my modified data is now R, 2R, 3R and so on and NR. So now variance of this data will be, we can write this as sigma of actually mean of their squares. Mean of their squares means you can add their squares by taking R square common, and then it is just the sum of squares of first n natural numbers, which would be n into n plus 1 into 2n plus 1. In fact, I have already taken the sigma, so this sigma is not needed. You can check, this is actually the sum of squares of all these numbers, because R square has been taken, then it is the sum of squares of first n natural numbers. I think divided by 6 will also be there. And if I have to take the mean of these squares, I will be dividing it by n, because these are n in number. And I will be subtracting the square of their means. Square of their means, first mean, what will be the mean? The sum of all these data will be R common, n into n plus 1 by 2, that will be the sum of all these data, and mean I have to divide by n, and then I have to do the square of this. So this is what I am looking for. So here you can see this n will cancel this n here, this n will be cancelling this n here. I can take R square common, I can also take 12 common. So R square upon 12 if I have taken common, and also I think n plus 1 can be taken common. Then what I will be now left with, I think I will be left with 2 into 2n plus 1 here minus 3 times n plus 1 here. So you will be getting R square into n square minus 1 upon 12. This is 4n minus 3n, n minus 1. So answer will be C. They are all, this question could have been done directly without doing anything. Why I am saying so? Suppose I am having only one data A1, which means n is 1. Okay. Now if only data is A1, its square of means, its a mean of squares or square of means will be same thing. So your value has to be 0, isn't it? For n is equal to 1, if it is 0, so answer will be either C or it will be D. If it is D, then it is independent of R. Okay, now maybe you can do one thing, you can take n is equal to 2 and you can take A1 and A1 plus R, and then you can do the calculation, you can check that it is dependent upon R, so answer will be C, not D. So this is how it could have been done, although this question, the reasoning behind, or the whosoever made this question, he would have thought of this property of variance while making this question. So this was not easy question, I will say, because if you start doing this question by writing that first my AI would be A1 plus I minus 1 into R, and then doing the square and then taking the sigma, it will become a huge question. Okay, so I think you are getting what I'm trying to say. Now coming to question number 6, a father wants to distribute a certain sum of money between his daughter and son in such a way that if both of them invest their shares in the scheme that offers compound interest at 25/3% per annum for T and T plus 2 years respectively, then the two shares grow to become equal. If son's share was rupees 4320, then the total money distributed by the father was. Okay, now daughter is given the amount which she will be investing for T years, and that son will be investing it for T plus 2 years. Okay, now and after T years and T plus 2 years respectively, their shares grow to same amount. So here you can think of that 4320 which was given to the son, and this was given for T plus 2 years, and the formula for final amount in that compound interest formula, it is 1 plus R by 100. So 25/3 upon 100 here, and this raised to the power T plus 2, that will be the amount which son will grow after T plus 2 years. Now if A is the amount that was given to the daughter, she will be able to grow this amount to this raised to the power T, and they both are equal, as they have given the two shares grow to become equal. So here you can see this will be cancelling this power T. So this 4320 into here, it will become 325 upon 300, and whole raised to the power 2 will be equal to A. So here this A will be equal to 4320 into, I think I can simplify by cancelling by 25. So 25 will cancel it, I think 13 times, and 25 will cancel it 12 times. So we will be getting this as 169 in the numerator upon 144 in the denominator. So this number 4320 is divisible by 9. 4 plus 3 7, 7 plus 2 9. Yes. So 9, if I cancel it, it will be 9 4s are 36, 7. So 9 8 is 72 and 0, and it will be 16. And this 16 will cancel 480 30 times. So if you multiply 30 with this thing, it will be 0. 3 9s are 27, 3 6s are 18 plus 2 20, 3 1s are 3, and plus 2 5, I think. So 5070 is the amount that will be given to the daughter, and already 4320 was given to the son, and they are asking the total money distributed. So the sum of these two will become 9, 3 and 9. So 9390. Yes, so answer for this should be 9390, that is B. Easy question, you just have to do the calculation. Okay. Now coming to the next question, number 7, let alpha denote a real number, the range of values of mod alpha minus 4 such that mod of alpha minus 1 plus mod of alpha plus 3 is less than or equal to 8 is. Okay. Now dear all, I will tell you this with the help of the meaning of mod. As you all know, mod A minus B actually represents distance between A and B on distance between A and B on real number line, if A and B are real numbers. Okay, so here this alpha is a real number, and this expression I can think of the distance of alpha from 1 and distance of alpha from -3, and the sum of these two distances is less than or equal to 8. So I hope you all can see that if my alpha is between -3 and 1, the sum of distance has to be 4, yes or no? If I take my alpha between these two, -3 to 1, because distance between -3 to 1 is 4, so if my alpha is here, I think this sum has to be 4, which is definitely less than 8. That means all the alpha which are between -3 to 1, they will satisfy it. Now, if I take my alpha to be bigger than 1, maybe here, okay, then you can see the distance from 1 and distance from -3, they both will be more than 4, because if my alpha is here, okay, so distance from 1 and distance from -3, they both will become more than 4, and we want this to be lesser than 8. So I think at most I can reach to this, I can increase this alpha to be 3 only. Why I am saying 3? Because then the distance from 1 will be 2 and distance from -3 will be 6, and these distances are getting added, so that is the maximum possible value of alpha that we may have. I hope you are getting what I am trying to say that. And similar to this, my other extreme, my alpha can be -5, because this point -5 is at distance 2 from -3 and is at distance 6 from 1. 6 plus 2 is 8. If you go any further on the left of -5, this sum will become greater than 8. So I think we have got alpha to be from -5 to 3. If you are not comfortable with this, what I can say, you can make the cases. And what will be the cases? Cases would be that first you take alpha between 1 and -3. Then you make the case 2 when alpha is greater than 1. And another case you make when alpha is less than -3, less than or equal to -3. And you can find by our usual way, my answer for alpha will also come out to be -5, 3. In fact, there is one more way of doing the same thing. We make the graph of this alpha -1, mod of alpha -1 and mod of alpha +3. Then also we can do it. Now, any way you do it, your alpha is going to be -5 to 3. Then alpha -4 will be taking values from -9 to -1. Okay, and then its mod of alpha -4 will be, I think, 1 to 9. We just have to do these numbers positive. So answer will be C, that is 1,9. Okay, so this is how this question can be done. I hope you have understood this distance method. If not, please repeat this video and please see it again, because that is one very easy method. Okay, coming to 8th question. It says for each natural number k, choose a complex number zk with mod of zk is equal to 1 and denote ak, the area of the triangle formed by zk, izk and zk plus iota zk. Then which of the following is true for the series given below? So first let us try to find out this area AK. To find that, I will make this diagram. We are given this zk has mod equal to 1. From origin distance will be 1. Iota zk, which will be just the rotation of zk by 90 degree, because iota has argument equal to 90 degree. So here this will be 90 degree and this length will also be 1 only. Now zk plus iota zk can be found by making a parallelogram, which here would be a square, because these two lengths OZK and OIZK, they are same and they are at 90 degree. So this parallelogram will be a square. So this will be this point Z plus iota ZK, ZK plus iota ZK. Now they are saying AK is the area of the triangle formed by this, this and this. So this is the triangle which we are looking for. In fact, this triangle or the triangle OZK, IZK, they both will be same. So here this AK will be actually equal to half into base into height. You can use, because this triangle is right angle, so that will be 1 by 2. So one thing is that AK is not dependent upon K. In fact, why will it be dependent on K? Because all ZK which are having magnitude equal to 1, you will be getting same area of the triangle. So AK will be half, and now we are looking for this summation half raised to the power K, as K vary from 1 to infinity. So I think this becomes a simple GP, half plus 1 by 4 plus 1 by 8 and so on. So sum of all such GPs always converges. So it is not dependent upon ZK. It converges only if ZK lies in same quadrant. It always converges. Answer will be C. In fact, you can find the sum of this GP, which will come out to be 1 only. So answer will be C for this question. Now coming to next question. The function y is equal to e power kx satisfies this relation for exactly one value of k, two values of k, three infinite many value of k. So here I think if y is this, we can find dy upon dx very easily. It will be k common e power kx. If I do differentiation 2 times, d square y upon dx square, it will be k square into e power kx. Okay, and because this satisfies it, we can put all these values here. So my first bracket, I think it will be, we can write k square plus k into e power kx. Then coming to the second bracket, in this I can write k minus 1 into e power kx. And on the right hand side, y is e power kx and dy upon dx is k into e power kx. E power kx is never 0, so we can definitely cancel it. And then you can check, we are getting k common, k plus 1, k minus 1 is equal to k. You can take k common and you can write this as k square minus 1 is equal to 0, which gives us either k will be 0 or k will be root 2 or it will be minus root 2. Okay, so I think there will be 3 values. Even this 0 is also satisfying. You can check. If k is 0, this y will become 1. And you can put y equal to 1, this bracket will be 0. And here this is also 0. So whatever it is, I think it is 1 minus 1 only, but still it is satisfying it. So there will be exactly 3 distinct values of k. So answer for this question will be C. I think this is easy question. I will call this as an easy question. Now coming to the 10th question, it says for a real number theta, consider the following simultaneous equations. Cos theta x minus sin theta y equal to 1, sin theta x plus cos theta y is equal to 2. Number of solutions of these equations in x and y is. Dear all, please understand, I can think of these two as straight lines. Okay, and at how many points they are going to cut will determine whether there will be 0 solution, 1 solution, infinite solutions or finite solutions. Okay, now to do that, I think you can check the product of coefficient of x, which is cos theta into sin theta, plus product of coefficients of y, which is minus sin theta into cos theta. And if you check, this becomes equal to 0. And that's a very important result in straight lines, that these two lines are perpendicular. So these lines are perpendicular, yes or no? In fact, what you could have done, you could have done it other way also, like you can write y is equal to cot theta into x minus 1 upon sin theta, which will give you the slope of this line to be cot theta, and similarly for other one, slope will be minus tan theta, and you can check their product is becoming minus 1. That means these lines are perpendicular. Now two lines, if they are perpendicular, they have to intersect each other. No one can stop them, and they will intersect exactly at one point. So number of solutions of these equations will be 1. Okay, in fact, those who know the Cramer's rule, you can use that D also, which gives you cos theta minus sine theta, cos theta, and the value of this determinant comes out to be 1, which is not equal to 0. This which clearly says it has to have unique solution, one solution only. Okay, coming to the next question, that is 11. In the range x between 0 to 2 pi, equation has. Now dear all, please understand, if cos of sin x is 1 by 2, okay, so this sin x has to be equal to 60 degree, or in radian pi by 3. In fact, cos is an even function, so even if it is plus pi by 3 or minus pi by 3, cos will give you 1 by 2. And I think these are the angles with smallest magnitude for which cos gives you 1 by 2. If you draw the graph of cos, which is something like this, so my value 1 by 2 will occur at pi by 3 and minus pi by 3. It will again occur, but it will be a bigger value than pi by 3. In fact, you can write plus minus 2 pi plus pi. I think it will be 2 pi minus pi by 3. Then it can be plus minus 2 pi plus pi by 3 also, and so on and so on. But dear all, please listen carefully. Even this pi by 3 thing is bigger than 1. Pi is 3.14. So this pi by 3 is greater than 1. So this sin x equal to plus or minus 1 plus or minus pi by 3 is just not possible. So for any real value of x, whatever its range is, you cannot have cos of sin x is equal to 1 by 2. So there will be 0 number of solutions. I think easy question, very easy question I will say. Now coming to question number 12, in which we are given a particle is allowed to move in xy plane by choosing any one of the two jumps. Move 2 units to the right and 1 unit up. That means my x coordinate will increase by 2 if you move 2 units right, and y coordinate will increase by 1 unit. Or move 2 units up, so x coordinate will be, y coordinate will be increased by 2 units and 1 unit to right, so your x coordinate will increase by 1. So this way we have to move, either move 1 or move 2. Now we are given P point as 30, 63 and Q as 100, 100. If the particle starts at origin, then P is reachable but not Q, and so on. Now dear all, to check what is reachable, what is not, I will say we took n number of moves which was 1, and we took m number of moves which was 2. Okay, so if it is so, my x coordinate will increase by 2n units plus m units, because in n moves 1, my x coordinate will increase by 2 each time, so 2n, and in m moves 2, x coordinate will increase by 1 each time, so 2n plus m. And similarly, y coordinate, this was my x coordinate. Similarly, if I do it for y coordinate, it will be n plus 2m. Now, if I want to know whether P is reachable or not, I will be solving it for this to become equal to 30, because we started with origin. So x coordinate, y coordinate both were 0, 0. Now P has 30 and 63. So this is what we will be getting. Now to get, I think here it is 2, not 3, it is 2. And this is 2m, not n. Now to get the values of m and n, what we can do, we can multiply this by 2 and subtract. This will be 2 into 2, 4. So here we will be getting 3n is equal to 60 minus 63, I think minus 3. So n will be equal to minus 1. I think this is not possible, because you cannot take negative number of steps. Okay, and similar to this, if it would have been 100, 100. So 2n plus m will be 100, and n plus 2m will also be 100. So same way, if I do it by multiplying by 2 and subtracting, I'll get 3n here, and we will be getting 100 here, which gives n is equal to 100 by 3, which is not an integer. That means having reaching 100, 100 is also not possible. So neither P nor Q is reachable. So answer will be D. Okay, easy question once again. Coming to the next one, that is 13. For a real polynomial in one variable p, let zp denote the locus of point x comma y in the plane such that px plus py is equal to 0. Then there exist polynomials q1 and q2 such that z of q1 is a circle, z of q2 is a parabola. There does not exist any polynomial q such that zq is a circle or a parabola, etc. Now everybody please listen carefully. What they are saying, suppose, just to understand, suppose my zp real polynomial in one variable. Let me take px as a quadratic, just one simple quadratic, x square plus ax plus b. I could have taken leading coefficient also, but I have taken leading coefficient as 1. Then this py has to become equal to y square plus ay plus b. Now if we add these two and I equate them to 0, you can see it becomes equation of a circle, isn't it? X square plus y square plus ax plus ay plus 2b is equal to 0, which is the equation of circle. If leading coefficient was different also, maybe you could have taken k here, then you will have k here also. In that case also you can check, you can get k here, then also it will represent a circle. Okay. Now please listen carefully. Why it is representing circle? Because we have equation of circle like x square plus y square plus 2gx plus 2fy plus c, in which we can write this equation by eliminating, or rather splitting two polynomials, one in terms of x, in which I will be putting x square, 2gx and one part of c, and I will make one more polynomial in which one more polynomial in terms of y, where I will be putting y square, 2fy and the remaining part of c. So this equation of circle can be written this way, in which two polynomials, one in terms of x, one in terms of y, are written. Okay, so that means there can be a possibility, there can exist polynomial q such that zq is a circle, zq is a circle. Here they are saying there exists polynomial q1 and q2, zq1 is a circle and zq2 is a parabola. Now coming to the parabola thing. Dear all, as you know from that theory of conic section, the general equation of parabola is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. So what we notice here, that there is a term in which x and y are coming together. Okay, so if that is so, I think px plus py will not be able to give you the terms where x and y are together. One more thing, even if you think that maybe h was 0, suppose that h was 0, but do you know there is a condition in that parabola that h square is equal to ab. H square is equal to ab is the condition in the parabola. So if h is 0, then a and b, they both will become 0. Sorry, one of them will become 0. Maybe a will be 0 or b will be 0, or both can also be 0. If both are 0, then it cannot be equation of parabola, then it will be just a linear equation. But if a is 0, b is not, or work converse, then what you can think of, that if a is 0, suppose a is 0 but b is not 0, and I am assuming h is 0, then it will be a quadratic in x, but it will not be a quadratic in y. So you are not actually writing px and py completely, because in px and py we just have to replace x by y. So both should have same polynomial. Whatever polynomial was there for px, same will be for py. The only difference would be that x will be changed by y. But here we are talking about that it is a quadratic in x, but it is a linear in y, or I think converse. It is linear in x and quadratic in y. That means it cannot be a parabola in any scenario, whether h is 0 or h is not 0. So answer for this in my opinion should be there exists a polynomial q such that this zq is a circle, but there does not exist any polynomial p such that zp is a parabola. So answer would be C. Okay, now coming to the next question, 14. We are given px is equal to x power 4 a3 x cube plus a2 x squared plus a1x plus a0 be a polynomial in x with real coefficients. Assume that p0 is 1, p1 is 2, p2 is 3, p3 is 4. Dear all, please see the pattern. At 0 value is 1, at 1 value is 2, at 2 value is 3, at 3 value is 4. And because px is a polynomial, so can I say that px, I am using small x, or let me use also bigger x, that capital X. So can I say that px minus x plus 1 is equal to 0 is satisfied by x is equal to 0 also. If you put x is equal to 0, you get p0 minus 1 is 0. It is satisfied by 1 also because p1 minus 2 will be 0. It is satisfied by 2 also because p2 minus 3 is also 0. It is satisfied by 3 also. So what we have obtained actually that this expression, which is supposed to be a biquadratic, is having 4 roots 0, 1, 2, 3. So why can't we say directly by factor theorem that px minus x plus 1 will actually be having these 4 factors, x minus 0, x minus 1, then x minus 2, and then x minus 3. In fact, this leading coefficient will also be 1 because this x power 4 term in this expression will come from px only. X plus 1 is just a linear. So this k will also be 1. Let me write this here as 1. Now they are asking what will be my p4. So let us put x is equal to 4. We will get p4. So p4 minus 5 would be equal to 4 into 3 into 2 into 1. That is 24. And 5, if you bring it here, p4 will become equal to 29. And that is the answer of this question. Easy question. This is one very standard problem. I have been doing this question in my class for at least 8 years or 10 years maybe. So this is one very standard question. You should, kind of remember this kind of tricks in such questions. Now coming to the next question, that is 15. Let f be a real valued differentiable function defined on real number line R such that its derivative f dash is 0 at exactly 2 distinct real numbers alpha and beta. Okay. Then alpha and beta are the points of local maxima of the function f. Alpha beta are the points of local minima of the function f. Okay. So what we are given that f dash alpha is 0, f dash beta is 0. So dear all, please beware of such things. These questions are kind of trap for you. Yes, it is true that f dash is 0 at alpha, but we are not given that about alpha the sign of f dash is changing or not changing. If it is changing, then only it will be a point of maxima or minima, otherwise it is not. So here, as you can see, there is one option given data is insufficient to conclude about either of them being local extrema point or not. So I think I will go with D. Let me tell you why. There can be few examples. Let me give you a few examples like this. Suppose this is my f and here this is alpha and here it is beta. So you can see f dash alpha is 0, f dash beta is also 0. But here you can check before alpha function was increasing, after that it was decreasing. For beta, before it was decreasing, then it was increasing. So these points are point of maxima and minima. But there could have been a possibility that you could have had a point of inflection at alpha where my derivative is 0, and same for beta also, where also derivative is 0, but it is increasing before that also, it is increasing after that also. So this at point of inflection, derivative will be 0, but derivative will not be changing the sign. That means you cannot conclude whether it will be point of maxima or minima. Here you can read this question once again. It's a real valued differentiable function defined on real number line R such that its derivative is 0. They have said only derivative is 0, but they have not said before alpha, after alpha, before beta, after beta, what are these signs. So we will be going with D only. So answer should be D. Now coming to the next question, that is 16. In this question, a school allowed the students of a class to go to swim during the days March 11th to 15th. So March 11th, March 12th, 13th, 14th and 15th. So there are total number of 5 days. Minimum number of students the class should have had that ensures that at least 2 of them went to swim on the same set of dates. Okay, now please listen carefully. They have given option 6 also. It looks like that there are 5 days. Okay, so maybe if there are 6 students, there has to be at least 2 students which will be going on the same day. Okay, maybe if there were 5 students, I could have had like that, student 1 went to this date, student went to this date, 3 to this, 4 to this, 5 to this. Okay, but if there are 6, then 6th student has to go on any one of these dates. Let us say 6 here. But what they are saying, minimum number of students the class should have had that ensure that at least 2 of them went to swim on the same set of dates. So it looks like S1 and S6 are going on the same date. But is it not possible that S1 also goes on this date also? Because swimming pool is a big, any number of students can go there. So here S1 and S5 are going on this 15th of March, but S6 is not going. So we cannot claim that these 2 students, S1 and S6, are going to swim on the same set of dates. Then what is the meaning of this question? Please understand. If I have 5 dates, okay, 11, 12, 13, 14, 15. So I am a student, suppose, then I may make my schedule as following. I can say yes or no to this date number 11. I can say yes or no to date number 12. I can say yes or no to date number 13, for 14 and for 15 also. So you can see, as a student, I will be having 32 possible schedules to go or not to go to the swimming. In this 32, there will be one possibility in which I will be going on all the 5 days. There will be one possibility where I will not be going on any of these 5 days. But there are total number of 32 possible schedules that I can have. Now, assume I want all students to have different schedules. So I hope you are getting, if I am having 32 students, I can manage to have 32 different schedules for 32 different students, isn't it? In which one of the student will not be going at all, one of the student will be going on all 5 days, one of the student will be going on 1 day, some of them will be going on 2 days, and like that. But if I am having 32 plus 1, that is 33 students, then all 32 distinct schedules are already exhausted. So this 33rd student has to follow one of the schedule that has already been followed by one of first 32 students. So if I am having 33 students, at least 33 students, then one of them will have to have, two students will have to be there, which will be having same set of dates where they will be going. So answer for this is 33, it is not 6. 121, it is not at least. Otherwise, in 121 also, there will be many students who will be following same schedule. Okay, so this is what this question is. Now coming to question number 17, which says let A1 less than A2 less than A3 less than A4 be positive integers such that summation of 1 upon AI, I from 1 to 4 is equal to 11 by 6. Then A4 minus A2 equals. Now please listen carefully. Here, if I increase the values of A1, A2, A3, A4, the reciprocal of them will become lesser. So if I increase A1, A2, A3, A4 beyond certain value, their sum may not be equal to 11 by 6. For example, if I take my A1 to be greater than or equal to 2, and because A2 is greater than A1, A3 is greater than A2, A4 is greater than A3, then my maximum sum of 1 upon A1 plus 1 upon A2 plus 1 upon A3 plus 1 upon A4 will be, if I take some of these reciprocal will take maximum only if I choose to have minimum possible values of A1, which is 2 here because I have made the condition A1 greater than or equal to 2. Then this will be 1 upon 3, then this will be 1 upon 4, this will be 1 upon 5. And if you add them, I think you will have to take the LCM, which will be 60. So here it is 30, this is 20, this is 15, and this is 12. So you will be getting this to be 50, 65, 77 upon 60. 11 upon 6 is close to 2 or precisely 1.8 something. Whereas this will be 1.3 something. So you can see it is less than 11 by 6. So if someone choose A1 to be 2 or higher, then this sum cannot become equal to 11 by 6. So which directly says that A1 has to be equal to 1. Okay, I will tell you one objective method also, but before that let us understand this properly. So then 1 upon A2 plus 1 upon A3 plus 1 upon A4 will be equal to, I will be subtracting 1 that side, so it will become 5 by 6. Now same way what I am going to do now, because my A2 is greater than 1, so it can be either 2 or 3 or so on. So let us explore if it can be greater than or equal to 3 or not. I will be proceeding same way, 1 upon A3 plus 1 upon 1 upon A2, 1 upon A3 and 1 upon A4. The sum of these reciprocals, the maximum possible value of this would be 1 upon 3, 1 upon 4, 1 upon 5. And you can do the similar calculation here also. I think this 30 will not come here, so this will be 47 upon 60. And you can check 5 by 6 is 0.8, greater than 0.8 actually, and this is less than 0.8. So here this is less than 5 by 6. So once again this A2 cannot be greater than or equal to 3. So this A2 has to be equal to 2 only. So far we have found that A1 will be 1 and we have found A2 to be equal to 2. So remaining 1 upon A3 plus 1 upon A4 will be equal to 11 by 6 minus 1 by 2, which will be 5 by 6 minus 3. So I think it will be 1 by 3. 5 by 6 minus 1 by 2. 2 by 6, 1 by 3. That is correct. Now, my A3 could be 3 also, because A1 is 1, A2 is 2. But I think if I take A3 as 3, because if A3 becomes 3, then A1 upon A4 will become 0. As otherwise, this 1 upon A4 will be 0. That is not possible. So A3 cannot be 3. So A3 can be 4. If A3 is 4, 1 upon A4 will be equal to 1 upon 3 minus 1 upon 4. It is 1 upon 12. So I think we are getting A4 to be 12, and all these values are integer. But let us explore if other possibilities is also there or not. If I take A3 is equal to 5, if I take A3 is equal to 5, I think 1 upon A4 will be equal to 1 upon 3 minus 1 upon 5, which will give you 2 upon 15. That means A4 will be 7.5. That is not possible because we are looking for positive integers. Now, if A4 is 6 or greater than 6, then 1 upon A4 plus if A3 is 6 or more, then 1 upon A3 plus 1 upon A4 will be at max 1 upon 6 plus 1 upon 7, isn't it? And which is lesser than 1 upon 3, which we are looking for. So this is also not possible. So I think that is the only possibility. So I am saying that A1 will be 1, A2 will be 2, A3 will be 4, and A4 will be 12. In fact, after this step, This Diophantine equation can also be used by taking LCM and writing product of two integers. That way also it can be done, and you can see these will be the only possible solution. So here A4 minus A2 has to be 10. That is the answer for this question. Little tricky question, but let me give you one objective method also. Please see how. Can you see that 11 by 6 is 1 plus 5 by 6, which I can write as 1 by 2, 1 by 3 and 1 by 12, I think. By doing some hit and trial, it can be seen that 11 by 6 is equal to 1 plus 5 by 6. 5 by 6 further can be broken down into 1 by 2 plus 1 by 3 plus 1 by 12. So this way, I think this will be 1 by 4. By checking your calculations, by doing hit and trial, you can check these are the values we are getting. And because of the way they are asking, there should be only one answer. You can rely upon these values also. There is none of these options you can see. So you can rely upon this also, but this was the proper method which I have discussed with you. Now coming to the next question, that is 18. 3 children and 2 adults want to cross a river using a rowing boat. The boat can carry no more than a single adult, or in case no adult is in the boat, a maximum of 2 kids. The least number of times the boat needs to cross the river to transport all the 5 people is. Okay. So let us make 2 ends of the river, and in the beginning we are having 3 kids, 2 adults. So in the beginning, I will send the boat from one end to the other by either sending 1 adult or 2 kids. But if you send 1 adult, then this boat will go there, but how will it come back? If you bring that adult back, then effectively we have wasted 2 attempts or 2 rounds. So this first attempt has to go with 2 kids only. Okay, but then 1 kid has to bring back the boat. So effectively, now I am having 1 kid here. Okay. And after doing these 2 rounds, I am having 2 kids here and 2 adults here. So effectively, in 2 rounds, I have sent 1 kid there. Then, now I am free to send either 2 kids there, or maybe 1 adult can also be sent here now, because if you send 1 adult here, then there is 1 kid out there who can bring this boat back. So after this, we will be having only 1 adult here, because this 1 kid will be coming back. So effectively, after making these 4 rounds, we are having 3 kids here and 1 adult here. So in these 4 rounds, we have sent only 1 adult. So similar to this, if I make 4 more rounds, 1, 2, 3 and 4, then you can see once again 2 kids will be going there, 1 kid will be coming back, then 1 adult will be going there and 1 kid will be coming back, and we will be having 3 kids here, but 2 adults will be there. 2 adults will be there. So 8 rounds, only to send 2 adults there. Then now we will be sending definitely 2 kids here. So, but 1 kid has to come back so that your boat is back, and now you will be having 2 adults, 1 kid here, and now we are having 2 kids here. Now after this point of time, because there are 2 kids and both the kids can go in 1 round of this boat, so we can send 2 kids in the next round, and we will be having 2 adults and 3 kids here, and now there is no need to bring this boat back. And also when they all will be reaching there, then who will bring that boat back? So this boat ultimately has to be there in that other end of this river. So you can see total of 4 rounds to send 1 adult, 4 rounds to send other adult, and 3 rounds to send the 3 kids. So 4 plus 4, 8 plus 3, 11. To make sure that it is the least possible number of rounds, you can check whether we have wasted any round or not. You can check. My first round should start with 2 kids only. Then to bring this back, to bring this boat back, I have to bring this 1 kid along with this boat, otherwise you cannot move further. So this round is also fine, justified. Then in this round I have sent one adult, and I cannot send more than one adult in one round if one adult is going, so this round is also justified. Then one kid is to bring back the boat. Then again we are sending two kids, that is also justified. Then one kid, this is also justified, this is also justified. Okay, so this way you can check all the 11 steps I've justified. We have not made any extra round, or we have not made extra times boat has crossed the river, so answer will be 11 only. Okay, so this is how this question is done. Now coming to next question, that is 19. We are given M is a 3 into 3 matrix with all entries being 0 or 1. Then all possible values of determinant M is R. So obviously 0 has to be one of the value, and it is given in all the 4 options also. So we should not take any time to find out whether it is 0 is there or not. Similarly 1 is also in all the 4 options. In fact, all these zeros, the value 0 can be seen if all are 0 0 0 0 or 1 1 1 1, you will get 0. This 1 can also be seen easily if you put all the elements in the diagonal, and you put all the ones in the diagonal and zeros in other places. So you will be getting 1, and if you interchange any two rows or columns, then -1 will also be there. So I think these are very much obvious. Now to check whether 2 is possible or 2 is not possible, I will tell you 2 ways. First of all, let us assume my matrix is A1, A2, A3, B1, B2, B3, C1, C2, C3. Now there is a direct method to expand this matrix where we multiply these elements in the diagonal. So we can write A1, B2, C3 plus A2, B3, C1 plus A3, B1, C2. So this diagonal, then A2 multiplied with B3 multiplied with C1. There is a direct method, or you can expand along any rows or column. Then also you can check these 6 terms will be coming. These are 3 terms with plus sign. Then there will be 3 more terms with minus sign. And these will be along other diagonal, you can say A3, B2, C1, A3, B2, C1 minus, then it will be A1, B3, C2, and then minus what is remaining? I think I have not taken A2, so A2, B1, C3. Now there is one thing to notice here, that every element you can check, like A1, it is coming exactly once in these 3 terms, and it is coming exactly once in these 3 terms. So every element is coming in those 3 terms which are with plus sign, and exactly once in those 3 terms which are with minus sign. Now if I start with all the values with 1 1 1 1 1 1, so you can see all these will be 1 here, 1 here, 1 here, and these will also be 1 1 1 here. So obviously the value will be 0, and that can be concluded directly also. Now if I make one of the element as 0, let us say A1 as 0. So what you can see, if A1 is 0, this element will become 0, and this element will also become 0 if I put only A1 as 0. Remaining terms like A2, B3, C1, A3, B1, C2, or these 2 terms will be 1 1 only. So my value will remain now 0 only. Then how we can have 1, how we can have 2, please see. If I make 2 elements of this first term, that is A1 and B2, both to be 0 0. So what you can see, this first term, let me write it once again, A1 B2 C3 plus A2 B3 C1 plus A3 B1 C2 minus A3 B2 C1 minus A1 B3 C2 minus A2 B1 C3. So if I do this thing, if I make these two 0 and all 7 elements to be 1 1, so this will be 0, and because these 2 elements are 0, this will effectively make this term to be 0, and it will also make this to be 0, and this will be 1, this will be 1, and this will also be 1. So you can see my value will be 1. 1 plus 1 minus 1, so 1. Now, same way, if you do one thing, that if you make A1, B2 and also C3 to be 0. In this case also you can check, my first term will be 0, this one. These two terms will be 1, 1 because I have made these 3 to be 0, other 6 1. Other 6 are 1 only. So in that case, this will be 1, this will be 1, but this A1 will make this term to be 0, B2 will make this to be 0, C3 will make this to be 0. So you can see all these terms with minus sign will be 0, 0, 0. So 2 seems also to be possible and minus 2 will also be possible. You just have to interchange the rows or columns. So minus 2 is also possible. Now the question is whether 3 is also possible or not. Now in that case you can see if you want 3, that means I want these ones to be intact, but I want these 3 to be 0, 0, 0, isn't it? Then only I can have 3. But for that you have to make one elements or at least one elements of these 3 terms to be 0, 0, 0, so that they become 0, 0. But if you make any one of the elements of these 3 terms to be 0, they will impact the value of these 3 terms also. So you cannot have these 3 to be 1, 1, 1 and these 3 to be 0, 0, 0. So 3 is not possible. 3 is not possible. Okay, so answer here would be, I think, B. It is not C, it is not D. Okay, so coming to the next question, that is 20. In the following picture, ABC is an isosceles triangle with an inscribed circle with center at O. P is the midpoint of BC and it's the isosceles triangle. So P is the midpoint, that means it will be altitude also, it will be median also, it will be angle bisector also. And AB and AC, they both are 15, 15, 15, 15. And BC is 10, so BP will be 5 and PC will be 5. And they are asking OP, and I think OP is nothing but in radius of this circle. So I think this question becomes easier, isn't it? You can do one thing, you can use that formula delta upon S. There are other ways also, but I think this one will be easier, delta upon S. Delta will be half into base into height, base is 10, and to find height AP, I think we can use Pythagoras theorem, 15 square minus 5 square, which will be root 200. So this will be 10 root 2, 10 root 2. And upon S means it will be 15 plus 15, 30, 30 plus 10 is 40, 40 by 2 is 20. So this will be equal to, this 0 we can cancel. So 10 upon 10 root 2 upon 4, you can write this as 5 upon root 2. 5 upon root 2. So answer is B. Answer is B. So that can be one method. We could have done this otherwise also. Let me think what can be possibility. If I join O with B, this will be angle bisector. Okay. And we can, this angle, this is theta, I think it is B by 2, and cos B can be found by Pythagoras theorem only, or that, you know, how base upon hypotenuse, so 1 upon 3, base upon hypotenuse. From cos B we can find B by 2, and B by 2 will give us R. I think 10 B by 2 I think we need. 10 B by 2 will be R upon 5. And from cos B we can find 10 B by 2, and we can find from this method also. Now coming to the next question, that is 21, it says for every real number x not equal to -1, fx is given by x upon x plus 1, and we are writing f1 as fx and nx as f of fn minus 1x. That means f2x would be f of f1, which means f of fx. So we can write this as f of fx means x upon x plus 1. So if I use this result, it will become x upon x plus 1 whole divided by x upon x plus 1 plus 1. So if I take LCM, it will be x upon, I think, 2x plus 1. Now similar to this, if we find f3x, which I can write as f of f2x, and I have already found f2, so I will be writing this as x upon 2x plus 1 here, upon x upon 2x plus 1 here. So this will become x upon 3x plus 1. So you can see every time we are doing it, we will be getting fnx to be x upon nx plus 1. Now they are asking the product of this f1 minus 2, f2 minus 2, and so on fn minus 2. Now to do this question, I will use f1 to be, I think it will be minus 2 in the numerator and minus 1 in the denominator. In the next term, f2 minus 2 once again in the numerator, but in denominator it will be minus 3. Then f3, if I write, it will be minus 2 here and it will be minus 5. So you can see we can ignore minus signs because they are going to be cancelled, and this way minus 2 here, and the last one would be minus of 2n plus 1. So it is actually becoming 2 power n here and product of first n odd numbers 1, 3, 5 and so on, then 2n minus 1. So the answer for this will be A. Okay, others doesn't seems to be correct. A is the answer for this question. I think this was just the calculation based question. Now coming to 22, it says let the integer ai for I between 0 to 54 be defined by the equation 1 plus x square power 27 is equal to a naught plus a1x plus a2x square and so on a54 x power 54. Then we have to find a naught, a3, a6, all their sums, and these are all the multiples of 3. I think that's one very standard method for doing such questions. We put x equal to 1 omega cube root of unity, complex non-real cube root of unity, and omega square, and add. Okay, my left hand side will become 3 power 27. When we put omega, it will become 0. If we put omega square, then also it will become 0. Whereas my right hand side, you can check. Every time you put whether 1 omega or omega square, a naught will be added 3 times. 1 plus 1 plus 1. Whereas a1 will be added, a1 will be multiplied with first 1, then omega square. Effectively, it will become 0. For a2, also you can check. For when x is 1, it will be 1. When x is omega, it will be omega square. When x is omega square, it will be omega power 4, whom we can write as omega also. And then a3, if I write, it will be 1 omega cube and then omega power 6 and so on. So what you can notice here is that this 3 power 27 will be actually equal to 3a naught, then it will be 0. Then again it will be 0. Only those terms which are multiple of 3, they will remain, rest will be 0. So 3a3, then again 0, and then it will be 3a6 and so on. So whatever they are asking, a naught plus a3 and so on, this will be actually equal to 3 power 27 by 3. So that is 3 power 26. So answer for this has to be A. One very standard problem. We have seen such questions in JAIN mains also. In fact, 2000 maybe 17 or 16 in KVPY also there was such question. Now coming to next question, that is 23. This question says an examination has 20 questions. For each question, the marks that can be obtained are either -1, 0 and 4. One very standard format for JEE Mains type questions. For correct you get 4, for leaving you get 0, for incorrect you get -1. Okay, so and S is the set of possible total marks that a student can score in the examination. Then the number of elements in S is. Now to do this question, let us assume you have done X questions to be correct. You have left Y number of questions and you have done Z number of questions to be wrong. Okay, so this X plus Y plus Z has to be 20. Correct question cannot be left or wrong. Left question cannot be correct or wrong. Wrong question cannot be left or correct. So this is how X plus Y plus Z will be 20. Now my score S. My score would be, for correct number of questions I will get 4x. For wrong I will get -z. So that is what I am going to get. So I think that is very much obvious that maximum would be 80. If my X is 20, that all questions are correct. Now, what will be the next possible score? Let me write it here. 80 when X is 20. What could be the next score? If suppose I leave one question, but I do not do it wrong. So I am leaving this question because maximum can be when all are correct. So second highest would be when 19 are correct, but that remaining the remaining question is left. It is not wrong. That is 0. So here you can see this will be, I think, 76. So after 80, it is not 79 or 78 or 77. It is 76. I hope it is clear. What could be the next possibility? I think next possibility would be that you have done 19 correct, but you have not left one question, rather you have done it wrong. In that case, it will be 75, isn't it? So after 76, we are getting 75. This way it seems it will be very long question, but very soon you are going to get one pattern and I will tell you the logic also for that. I think next one would be that you have done 18 questions correct, but you have left the 2 questions so that there is no negative marking. Okay, in this case, we will be getting 18 into 4, 72 marks. So once again, there is a gap of 2 marks. 74 you cannot obtain, 73 we cannot obtain. In fact, let me write what are the questions marks that we cannot obtain. 79 here we cannot obtain, 78 we cannot obtain, and 77 we cannot obtain. But next time if you notice, what was the gap? After 75, 74 and 73. So this has reduced. Now, if my 18 questions are wrong, I have left one, I have done one question wrong, then also my score will be 71. Okay, and 70 can also be obtained when you have done 18 questions correct, you have done 0 question wrong, and you have done 2 questions wrong. 0 question left and 2 questions wrong. So there is no skip of any marks here. But when you will be doing next, that is 17, I think there will be 68. So only 1 marks we are skipping, that is 69. So from this pattern, can we assume all other marks will be obtained? The 68 would be when you have left 3 questions, we have done 0 question wrong. In fact, you can think of that you have, in this case, 17 questions were correct, 3 were left. Instead of 3 left, it could have been 2 left, 1 wrong, 1 left, 2 wrong, or all 3 wrongs. So this way you can reduce your score by 1 every time. So 68 to 67 will be possible, 66 will be possible, 65 will also be possible. And then next will be 64, which will be possible when X is 16, that is 16 questions are correct. Now, if 16 questions are correct, you have either left 4 questions or you have done them wrong. So because you have a liberty of switching values of Y and Z between 0 to 4, I think we will be able to get all the possible marks from 64 to 0. In fact, my last score will be -20, isn't it? When all questions are wrong. and from 67, 66 to all marks will be possible, like minus 19 is also possible because you have done 19 questions wrong and one left. So this way you can think of all marks are possible. So what are the all possible marks? I think we started with 80 and last marks is 20, including 0 if we do, it will be 121. But from these 121 different marks, 3 plus 2 plus 1, 6 are the marks that will not be possible. I think I have done one calculation mistake. 80 plus 20 is 100 only. 80 plus 20 is 100 only, and 1 0 including if I do 101 minus 6 will be 95. So the answer will be here 95. I will tell you one logic here. If you have done number system, let me tell you, because 4 and 1 are co-prime numbers, you can make any number with the linear combination of 4x and z, where x and z are integers. But the problem here was, because there was a constraint on z that x plus y plus z to be 20, and if x was 20, okay, so it will be 80, and after x becoming 19, my z can take only one value, that is either 0, it can take only two values, either 0 or 1. So I am not having that much of freedom. But if we were free to choose any value of z, then I think even these values can also be fitted into. But these are not possible because of this constraint. But after certain values, that constraint has also gone. So all these values are possible to get. So here answer will be 95. So this is how this question can be done. You can do it by coefficient method also, but I think this seems to be better method. Okay, now coming to the next question, that is 24. Chords AB and CD of a circle intersect at right angle at point P if length of AB, PB, CP, PD are 2, 6, 3, 4 units respectively, then radius of the circle is. So let us first make a diagram. We are given that AP is 2 and PB is 6. Similarly, CP is 3 and PD is 4, and they are intersecting at 90 degree. One thing I like to comment here, they could have avoided one of the value, because if we use the power with respect to P, you can see 2 into 6. 2 into 6 is equal to 3 into 4. That is correct. But they could have avoided the length of PD, because you can find with the help of power of a point with respect to a circle. So that way it could have been done. Now what I have done, I have taken O as the center and I have dropped the perpendicular on these chords, which will meet them in that midpoints. So N is the midpoint of CD, M is the midpoint of AB. So if N is a midpoint, the length of CD is 7. So you can see this PD would be PN actually. PN would be actually 7 by 2 minus 3, isn't it? Because NC will be half of 7 and this is 3. So this one will be half here, 1 upon 2. Okay. If we want to find the radius, I think use the Pythagoras theorem, it will be done. So OD, that is the radius, will be under root of ND square, that is 7 by 2 square. Actually, I will require this ON. So I think I should have joined this thing. If this is half, this will also be half because it is becoming a rectangle. So in this case, actually the length of AB is equal to 6 plus 2, 8. So this MB would be 4. MB would be 4. So here to find OB, I will use 4. OB actually. OB I will use under root of 4 square plus 1 upon 2 square. So that will be 16 plus 1 by 4. So that will be root 65 by 2. Okay, this could have been done this way also, because you can see this M is the midpoint of AB and this is 2 here. So PM will be 2 here. So this will be 2 here and this was 3 by 2 here. So using the Pythagoras theorem, so 2 square plus 3 by 2 square also we will get the same answer. You can check. So this will be 4 into 4, 16 4 into 4, 16. Let me check if it is correct. I think this was 7 by 2. Yes, 7 by 2. So 16 plus 49 is 65 upon 4. Same answer. So answer will be B for this particular question. Easy question, I think. Now coming to next question, that is 25. Here we are given that locus of points x, y in the plane satisfying this consists of. So dear all, please listen. I can write this as sine square x is equal to cos square y. Okay, now there can be two methods. One of them could be that cos square y minus sine square x is equal to 0. And if you remember, there is a formula that cos square y minus sine square x is actually cos of y plus x into cos of y minus x. This could have been done otherwise also, but this is one very easy method. So here cos of y plus x will be 0 or cos of y minus x would be 0. So in this case, x plus y will become equal to odd multiple of pi by 2. And n can be any integer. So you can see this will be a series of parallel lines. Similarly, this will also be a series of parallel lines equal to 2n plus 1 pi by 2. So locus of point x, y in the plane satisfying this will consist of infinitely many lines with slope 1 or minus 1. So answer will be C here. Okay, here you could have done this way also, that take either sin x equal to cos y and write this cos y is equal to sine of pi by 2 plus x, and then using trigonometric equation you can again check, it will be same thing. Okay, but I think this one is better. I would say best method. Now coming to the next question. Now coming to this question number 26, the number of integers n greater than or equal to 10 such that product is a perfect square. Now to do this question, we can use the formula for NC10, that is n factorial upon 10 factorial and n minus 10 factorial into n plus 1 factorial upon 10 factorial into n plus 1 minus 10, that is n minus 9 factorial. Now please check that what are the numbers that are already making perfect square, like n factorial is already making a perfect square. Upon 10 factorial is also coming with perfect square. Okay, now n minus 9 factorial will also come with perfect square if I multiply in the numerator by n minus 9. Okay, this n plus 1 factorial I have written as n plus 1 into n factorial, and this n factorial is multiplied with this and we get n factorial whole square. Please check this calculation. N minus 10 is one lesser number than n minus 9. So if I am writing n minus 10 factorial as n minus 9 factorial in the denominator, I have to multiply it by this. Now please see, all these numbers are perfect squares, whether they are in numerator or in denominator. We just have to focus on the product of these two to become a perfect square. Why I am saying so? Because this has to be an integer. Nobody can say that why it will be an integer. It has to be an integer. So because already these are perfect squares, so if these are also perfect square, and because they will be integers, so they will be, if perfect square, they will be perfect square of an integer. So we just have to make sure that n minus 9 into n plus 1 is some k square. And for that we will multiply it, we will get n square minus 8n minus 9 is equal to k square. If we make this as a perfect square, it will be n minus 4 whole square plus 16 minus 19, I think it will be minus 25 here, is equal to k square. So what we are getting, we can write it in two ways, n minus 4 square plus k square, n minus 4 square is equal to k square plus 5 square, and all these are integers. N minus 4 is integer, k is integer, 5 is integer. So this k and 5 should be Pythagorean triplet, and if they are Pythagorean triplet with 5, I think k should be equal to 12 and n minus 4 should be equal to 13. So n will become 17. Or what you can do, you can write this as n minus 4 whole square minus k square is equal to 25, one very standard method. So we will be getting n minus 4 plus k into n minus 4 minus k as 25. And they will be 1 into 25, because if they are 5 and 5, then I think it is not possible, because then one of them k has to be 0, I think. That is not possible. So here 1 and 25. So I will be taking n minus 4 plus k as 25 and n minus 4 minus k to be equal to 1. Adding them will give n minus 4 to be equal to 13, and that is what we got there also. So n is equal to 13. If you take minus 1 minus 25, then also you can check, but I don't think that it will be possible. Let me just think. Actually, this n minus 4 has to be greater than k. So they both will be positive, positive, yes. So n will be 17, sorry. N minus 4 will be 13 and n will be equal to 17. So what exactly they have asked? Number of integers. So I think answer is B, that is 1. And you can check for n is equal to 17. This expression will become 17 minus 19 is 17 minus 9 is 8 and 17 plus 1 is 18, which is square of 12, I think. 18 into 8 is 144, 12 square. Now coming to question number 27, which says let a greater than or equal to b, greater than or equal to c, greater than or equal to 0 be integers such that 2 power a plus 2 power b minus 2 power c is equal to 144. Then a plus b minus c equals. Now to do this question, first of all, I will try to explore whether b is equal to c is possible or not. If b is equal to c, then 2 power a will become equal to 144, because these two terms will get cancelled. But this is not possible because 2 power a is a perfect power of 2, but 144 is not. So this is not possible. Now what if a is equal to b and greater than c? We have already ruled out b cannot be equal to c, so we can check for this thing now. We will be having 2 power a plus 2 power a minus 2 power c is equal to 144. I can write it as 2 into 2 power a or 2 power a plus 1 minus 2 power c is equal to 2 power 4 into 9 here. Here c is lesser than a plus 1, so I can take 2 power c common, then it will be 2 power a plus 1 minus c, and a plus 1 minus c is still a positive integer, minus 1 is equal to 2 power 4 into 9. So from this what we are getting, that my c has to be 4, and because this will be an odd number, this is what which is giving us power of 2, and here this is what we are which is giving us power of 2. So c will be 4 and 2 power a plus 1 minus c minus 1 will be equal to 9. But this also seems to be wrong, because in this case we are getting 2 power some positive integer equal to 10, so this is also not possible. So here now I can say that a has to be greater than b, greater than c. Now this question will become easy. How? Please see. 2 power a plus 2 power b minus 2 power c is equal to 2 power 4 into 9. So can we say that c has to be 4? Yes, we can say. Why I am saying so? Because if I take 2 power c common, it will be 2 power a minus c, and this will be an even number because a is greater than c. So 2 power positive integer will be an even number. Similarly, 2 power b minus c will also be an even integer. Minus 1 is equal to 2 power 4 into 9. So this is even, this is even, minus 1 will be odd, and c will be equal to 4. So what we are going to get here, that 2 power a minus 4 as c we have found out as 4 plus 2 power b minus 4 is equal to 10, I can write. Okay, or let me write this as 2 power a plus 2 power b, and let me multiply by 2 power 4 both sides, so it will become 160. Now once again I can take, or I can write this as 2 power I think 5 into 5. So as per I did for 2 power c, I think I can do it for 2 power b also. A minus b plus 1 is equal to 2 power 5 into 5, and this gives us b to be 5, and 2 power a minus b plus 1 is equal to 5. So as b is 5, 2 power a minus 5 will become equal to 4, and this will give us a to be equal to 7. So you can see the values of a is coming out to be 7, b is coming out to be 5, and c is coming out to be 4. So answer here would be a plus b is 12 minus 4 is 8. 7 plus 5 is 12, 12 minus 4 is 8. So answer is B for this question. Okay. Now coming to question number 28. Number of integers n for which cubic equation has 3 distinct integer solutions. Now, distinct integer solutions they are saying. Let us say alpha, beta, gamma are the solutions. So you can see as there is no square term, so we can write alpha plus beta plus gamma is equal to 0. But sum of product of roots taken 2 at a time, alpha beta, beta gamma, gamma alpha, their sum will be equal to minus 1. Now, if I do the squaring of this thing, I will be getting alpha square plus beta square plus gamma square plus 2 times alpha beta plus beta gamma plus gamma alpha. I can write this as minus 1, and this will be equal to 0. And that is the very, very important step of this question, that we will be getting alpha square plus beta square plus gamma square is equal to 2, where alpha, beta, gamma all are integer, distinct integer rather. So if they are distinct integer, I think we can have alpha square to be 1, beta square to be 1, and gamma square to be 0. That is the only possibility, because we need 3 perfect squares and their sum to be 2. That is the only possibility. So here alpha will be 1, beta will be minus 1 because they are distinct, and gamma is equal to 0. We could have permuted alpha, beta, gamma, but end result will be same. The roots would be 1, minus 1, 0 only. There cannot be any other possibility. I hope this is clear. Now what they are asking? They are asking the number of integers n. Okay, because my roots are coming out to be 1, minus 1, 1. So n is actually negative of alpha, beta, gamma, that is product of all the roots. So it is coming out to be 0. So number of integers n, they are asking number of integers, not value of n. So answer will be 1, B. B will be the answer of this question. Be careful, n is coming out to be 0, and there is an option 0 also there, but they are asking number of integers n. So answer would be 1 here. This was the very important step here, because alpha, beta, gamma are the integers. There cannot be any other possibility than alpha square, beta square being 1, 1, and gamma square 0. And because distinct integers, so 1, minus 1, and 0. Okay. In fact, this is satisfying sum of roots to be 0 also, and this is satisfying sum of roots taken 2 at a time also to be minus 1. Now coming to question number 29, which is asking number of real solutions of equation x square is equal to e power x. So if I make graph with little bit of precision, I think we can conclude how many solutions we may get. Like for 0, e power x will have values 1. At x is equal to 1, e power x will have value equal to almost 3, somewhere here. So this graph will be going like this. Whereas graph of x square, if we draw, it will be upward parabola. At 1, its value will be 1. Okay, and it looks like the gap is going to be widened as we increase the values of x. Now to check, or you may do one more thing, you may put x is equal to 2 also. At 2 it will take just value 4, whereas at 2 e power x will be somewhere around 2.7 whole square, somewhere around 7. So it looks like the gap is going to be widened. But I'll tell you one more logic for this. Please see how. At x is equal to 0, the value of e power x is 1, whereas this x square will obtain this value at x is equal to 1, where its value is e. So let me draw it here, e. Now at this point, if you check slope of this graph is 2x and x is equal to 1, the slope will be 2 only, whereas at this point if you check the slope is e power x, that will be e. So the slope is more here than at this point. So then definitely this is going to increase rapidly than the graph of x square. Now you may ask that maybe later on the slope of 2 power x will take over the slope of e power x. For that, let us just compare e power x and 2x. Okay, you can check at x is equal to 1, this e power x is e and 2x is 2 only. But if I further differentiate, this slope is going to be 2 for always. Let us compare the functions e power x and hx is equal to 2 power x. Why I am comparing it? Please listen carefully. Its derivative would be e power x and its derivative will be 2. Okay, already we have checked that at x is equal to 1, this e power x was more than 2 power x. Okay, and slope of e power x you can check at x is equal to 1 or beyond x is equal to 1 will be far bigger than 2, because its slope is going to be 2 always, whereas its slope will also increase. So what we can expect that e power x will always be bigger than 2 power x, and hence you cannot even increase the slope of this graph x square than e power x, and we will be getting this graph becoming out of reach kind of thing to this x square. So there will be only one solution. So answer for this question has to be B. Dear all, if you do not make graph carefully, there can be other possibilities also like this. This is my graph of e power x, and the graph of x square could have been like this also. But in this case also, because e power x is an exponential function, it will take over. This e power x will ultimately take over, and there will be 3 solutions in this scenario. Or maybe there is a possibility that e power x and x square, they may touch each other at some point here, and then you may have solution as 2 also. But we have already checked these 2 possibilities are not there, hence answer will be B. Okay, now coming to the last question, that is 30. Number of distinct real roots of this equation. So here I will like to do this question by taking everything on one side. X sin x plus cos x minus x square, and then do the differentiation. If you check, you will get x cos x plus sin x minus sin x minus 2x. So this sin x cancelled, and x common, cos x minus 2. So that is the differentiation. Everybody listen carefully. You can check both sides functions are even, isn't it? Because sin x is odd, x is odd, so product will be even. So if we can check roots for x positive only, we just have to multiply by 2. Because whatever solution you are having for x positive, same number of solution will be for x negative also. So f dash x, if you check, it will be negative for all x to be positive, because cos x minus 2 is negative, and for x positive this will be positive, so this product will be negative. So f dash will be always negative, so fx is decreasing function. So if it is decreasing function, you can check f0 is coming out to be, I think, 1 here. Whereas if you make x larger, I think x square will definitely take over. This x sin x plus cos x is negative for larger values of x. So we can conclude, because it is strictly decreasing function, so for x positive, this function will have exactly one root, because it is strictly decreasing. You can think of this way, that x is equal to 0, it is 1, then it will be going negative at some point, after some point, and in between it will be intersecting this x-axis. and because this is even function, it will be doing same thing on the left hand side also. So number of distinct real roots for this will be 2. B should be the answer for this question. Okay, so this completes the solution of all the questions. Today I will not be posting any teaser question, rather I will be posting a teaser question in the next session when I will be concluding this paper. Okay, so this is all for today. Thank you so much, bacho, and please do attend next session also. Do watch next session also, because this will conclude both UGA and UGP. So thank you so much. That is all for today. Bye.